Hi, in this video, I'll be showing you problem number 54 of chapter 12, section 5. Determine whether the planes are parallel, perpendicular, or neither. If neither, find the angle between them, round to one decimal place. The first plane is x minus y plus 3z equal to 1, and the second plane is 3x plus y minus z equal to 2. Now, we are going to determine whether they are parallel, perpendicular, or neither. So the concept behind this is the two planes are parallel if their normals are parallel. They are perpendicular if their normals are perpendicular. If they are neither parallel nor perpendicular, they come under neither category, which means they make an angle between the two planes. So let's consider the concept first. Two planes are parallel if their normals are parallel. If ax plus by plus cz equal to d is the equation of a plane, then the coefficients of xyz, namely the component form a, b, c, will be the normal vector. And the normal is n, which has components a, b, c. So we know we can find out the normal vector to plane 1 and normal vector to plane 2. So n1 vector, which is the normal vector to plane 1, will be 1, -1, 3. Then the normal vector to plane 2, which is n2, is the coefficients 3, 1, and -1. 3, 1, -1. So we are going to find out whether the two planes or the two normals parallel. The two normals will be parallel if one is a scalar multiple of the other. So if we consider the number 3, which is 1 times 3, so which is 1 multiplied by 3 is 3. So that means every component of n2 must be a multiple of 3 of the first normal vector. But if you look at this -1 and 1, so 1 is not -1 times 3. So it is -1 times 3 is not equal to 1. So that means they don't maintain the same factor. So it's not the same scalar multiple of the other. So the components are not scalar multiple. That eliminates that the two normals are parallel, so the two planes are not parallel. The components of the two vectors are not scalar multiples of each other. Therefore, the two normals are parallel, and therefore the two planes are not parallel. So does it mean they are perpendicular? So we have to check whether they are perpendicular or not. Are they perpendicular? Are they orthogonal? Are the normals perpendicular to each other? The normals will be perpendicular to each other if the dot product of the two normal vectors end up as 0. So n1 dot n2 vector is, you multiply the corresponding components, which is 1 times 3 plus -1 times 1 and 3 times -1. You add them, and if it turns out to be 0, then the two vectors are perpendicular. Normals are perpendicular. That will mean the two planes are perpendicular. Are they? Let's check. So it's 1 times 3, -1 times 1 plus 3 times -1 becomes 3 minus 1 minus 3, which is -1. Absolutely, it's not equal to 0. That concludes that the two planes are not perpendicular. So let's see, that means that they fall under neither category. So the two planes are neither parallel nor perpendicular, which tells us that they make an angle of theta between them. Let's assume that theta is the angle. If the normals make an angle theta between them, then cosine theta would be dot product n1 dot n2 divided by length of n1 times length of n2. We already computed the dot product in the earlier case when we determined whether they are perpendicular or not, so which is negative 1 over length of n1, length of n2. The length of the vector will be square root of x component square plus y component square plus z component square. So if we find that out, it's square root of 1 square plus negative 1 square plus 3 square, which will be square root of 11. Same way, length of n2 will be 3 square root of 3 square plus 1 square plus negative 1 square, which will also be square root of 11. So cosine theta is equal to negative 1 over square root of 11 times square root of 11, which is negative 1 over 11, which we can find out by taking the cosine inverse. We can find out theta, which is cosine inverse of negative 1 over 11, which will be 95.2 degrees. We're asked to approximate to the nearest decimal. So make sure that you watch the videos for the lectures or attend the class for lectures to understand the concept and then try these problems. Hope this video helps.